There a little bit. Hello, everybody. Welcome to PNNL's Energy Storage webinar series. Today, I am hosting the Fleet Electrification webinar. My name is Christine Holland. I'm an economist at PNNL, and I will be moderating a panel of our experts. And before I jump in introducing our expert panel, I'd like to just talk a little bit about the work that we've been doing at PNNL. We've worked on a couple fleet electrification projects. One had the pleasure of working with two of our panelists today at Franklin Pierce School District and Tacoma Power. We looked at electrifying their fleet of buses, 65 buses and 48 transit vans, transitioning over a 20-year, assuming a 20-year transition period. We developed loads for the fleets using both traditional charging and smart charging, and we did an economic analysis. And when assuming full fleet transition and smart charging, we found that smart charging can save at a minimum $1 million over the 20 years, just based on deferred transformer upgrades and reduced demand charges. We also did a fleet V2G analysis. This was from the utility perspective. We looked at fleets of 50 vehicles for buses, delivery vans, and Ford F-150 Lightnings for a variety of utility applications, such as ancillary services and arbitrage. This was, we assumed that there was no flexibility in the driving schedules, so we got driving schedules from the fleet DNA, from NREL. The vehicles were used for their primary purpose, and it was just business as usual. So the fleet owners did not receive any price signals to use their fleets differently for V2G purposes. And we found that in the Pacific Northwest, using BPA prices from Snohomish Power PUD's perspective, that buses were cost effective for arbitrage purposes. In New York and California, using ISO prices, we found that using buses for frequency regulation, arbitrage, and spinning reserve in some instances were cost effective. So that was just some of the work that we did. And as I mentioned, we through the process of this, we worked with Franklin Pierce, Robin Hendricks, and Jeremy Stewart at Tacoma Power. And just wanted to give you, I'm gonna have Robin go first. And I just wanted to give you a brief bio here. So Robin is the Executive Director of Support Services at Franklin Pierce School District. He's been with the school for approximately 11 years and is leading their transportation efforts and capital construction program, including the purchase of 4 EVs, school bus EV, electric buses, and corresponding charging infrastructure. So Robin, I am going to turn it over to you now.
Thanks, Christine. Thinking about what you might be interested in hearing about in our experience about purchasing and operating electric buses, I thought you might be interested in hearing about our initial considerations when thinking about buying an electric bus and putting it in operation, then maybe our experience and lessons learned after we've had this bus in operation for a number of years, and then perhaps the changes that we wanted to make in that program before moving ahead with additional buses, and then finally our future plans. So on the slide here, you can see a map of Franklin Pierce School District. If you're not familiar where we're located, we're just south of Tacoma and just west of Puyallup and east of Lakewood. So as you can see from the map here, we have a fairly small geographic sense, small district, about 16 square miles. And we serve about 7,500 students operating about 65 buses. So next slide, please. So as you might be aware, we purchased and put in operation the first electric school bus in the state of Washington in 2019. Before that, we've been thinking about electric vehicles and wondering, if it would be a good fit. So some of our considerations before taking the plunge and getting this new technology, we looked at the shape and size of our district. Again, we're fairly compact. So we didn't have really long runs in a large geographic district. So that seemed to be compatible. We also examined the length of our routes, the individual routes, and found that we had routes that seemed to be a good fit for the range, the operation range that was available in vehicles at the time of purchase. So we also knew that we wanted to have a type D electric bus. That's been our standard. And so we wanted to go to the market and see, who made that type of a bus in an electric configuration. The range, of course, was very important to us. And so when we looked at type D electric buses, the range capability of the bus offering was very important to us. We had questions, not knowing a whole lot about this, about what the effect of terrain might be on the bus range, and the effect of operating heating and air conditioning and lights, especially during the colder parts of the year, to see if that would decrease the range to the point where we had a problem in getting the kids back home at the end of the day. We also were interested in what impact terrain and driving conditions might have on effective range. So I think we were aware that with regenerative braking, that in stop and go traffic, we might be able to gain some range just because of the regenerative braking. So we looked at that a little bit and factored that into our decision. Obviously, our shop was kind of on edge and ill at ease with the thought of bringing in a different platform, not knowing what the maintenance requirements were going to be. So we reached out to manufacturers and other clients in other states who operated these vehicles to get information about what their maintenance considerations were. At the time, the offerings, type D offerings that we saw did not include fast charging capabilities. So we thought we were going to be into a level 2 charger requirement, but didn't know, how fast they would charge and what the effect would be if we found ourselves needing a midday charge. We looked at our calendar. We have some early release days, some of our 3.5-hour early release, which might imply that we would not be able to get a midday charge. So we wanted to make sure we understood the effects of the calendar and those schedules on our range. We also didn't really know what a level 2 charge would cost and what kind of infrastructure would be required. The last thing that we were concerned about was, since we were buying the first electric school bus in the state of Washington, what would be the Washington State Patrol process for certification of this brand new vehicle? So those were the things that we investigated before taking the initial plunge. So next slide, please. So this is a picture of the bus that we purchased. It's a Bluebird Type D. This is a picture of the opening ceremonies when we took delivery on the bus. Governor came down, and there was a lot of interest in us adopting this technology. Next slide, please. So we purchased that bus in 2019. Of course, a lot has happened since 2019, notwithstanding the effects of the pandemic on school programs. So we've been running the bus since that time, since I think spring of 2019. And I thought I would share with you some lessons learned from that experience with that first generation 1 bus. We found that range, as you might expect, is an estimate, the little range gauge that you have on the bus. Initially, it has 100 units, supposedly roughly equivalent to 100 miles. That can change dramatically depending on a number of factors. Ambient temperature, if you're running the heater a lot, if you're running the lights a lot. We found, interestingly, that air conditioning did not affect range as much as the heater did. Driving habits from the driver was found to be a significant factor, and a careful driver could get a much more range out of the bus than someone who was not familiar with the vehicle and had just stepped in. So we made a decision early on to designate a single driver to that bus to get the most range out of it and to understand the capabilities of the bus with that variable kind of taken care of. We found that the terrain and driving conditions did not become a huge factor in range for the bus. And when we looked at the level 2 charger that we purchased for the bus, we found that we were able to take advantage of existing infrastructure that had been used for block heaters for diesel buses. So we already had the wiring, we had the electrical distribution, we just had to buy the level 2 charger. And so that was actually relatively inexpensive to put that in place, much less than we had originally thought. We did find that with, depending on the weather and the effective range on the bus, we frequently had to come in and top off during a midday charge just to make sure we had a comfort level to make those afternoon runs. We had looked into a little bit into DC fast charging, but because that first generation bus was not capable of receiving fast charging, of course, we did not go that direction, but we realized that the provision for DC fast charging would have been advantageous with that first bus. Maintenance considerations, the bus is largely just a conventional bus. So much of the maintenance is similar to a diesel, and most of that can be accomplished with our shop. It was only the high voltage component of the bus that required specialized assistance for maintenance and repair. And the dealership that we worked with been very good about providing that support. Kind of an unanticipated advantage that we found or lesson learned was that the passenger compartment is much quieter, as you might expect, than a diesel. And that's had a great positive impact on student management for the passengers in the bus and for the bus driver. So didn't anticipate that, but it's real. And of course, it's a nice advantage. Next picture, please. This gives you just a picture of kind of the business end of the bus. Instead of a diesel engine, you've got this electric motor and some high voltage wiring. So a little different, but really the rest of the bus is just a conventional bus. The picture on the right shows our level 2 charger. And I think all told, we spent about less than $10,000 in installing this because we had existing infrastructure. And so it was very inexpensive, much less than we had anticipated originally. Next picture. So after having run this bus for a few years, we then considered expanding our use of electric buses, but wanted to be careful as we considered that. So we again looked at our routes and found that we probably needed more range if we were going to expand our use of electric buses significantly. And we came to the conclusion that if we could find a bus with about 150-mile range, that would be ideal, probably for all of our routes. And so we looked for that in the market, and we were not able to find that. But we also needed to make sure that it would be approved by Washington State Patrol. We also thought about, well, do we need then to look at DC fast chargers to compensate for the range limitations that we were seeing? And or if we could just, find a bus with larger battery capacity, maybe we could get by with level 2 chargers. So when we were looking at fast chargers, they have a huge current draw from the utility. And so we engaged with Tacoma Public Utilities to see if there was even the capacity within the infrastructure, the utility infrastructure, to support widespread use of fast chargers. And in fact found that that would have been a challenge if we had tried to deploy that across all of our fleet. We didn't really have any idea of cost, and these things are not inexpensive, very, very expensive. And we also have concern about effect on our demand charges from the utility, and wanted to make sure we avoided peaks that would become very expensive over the course of the year. So we did become aware of fast chargers that have a battery storage, so they kind of trickle charge overnight, and then they're capable of transferring a large amount of current quickly from that battery storage. The advantage of that was obviously that we wouldn't have to impact the amount of, wouldn't have to impact the utility as much. But again, we didn't know really what the cost would be and what kind of infrastructure would be required. So next slide, please. So we made a decision to purchase 3 additional Bluebird Type D buses. This is the next generation bus. It has about 120-mile range, not the 150 that we were hoping for, but it is fast charging capable. We decided to then take the plunge and go away from level 2 chargers for this next deployment, and added two-headed, so in other words, you could support 4 buses, DC fast chargers with battery storage. The big advantage there was we were able to install these with no upgrade to the electrical transformer and or the conductors to the panel that would feed this. And it also reduced our concerns about exposure to demand charges. So,
wrap this paper pretty soon.
Sorry?
We need to wrap it up.
Okay. So next slide, please. Here's a picture of the fast charger and the wiring. And the next slide, please. So for now, after we put these in place, we're going to kind of hit the brakes for a bit, wait for the technology to move ahead with perhaps longer ranges, and our next charging configuration will be a mix of level 2 and potentially up to 4 more fast chargers. We looked at vehicle to grid and found that was not a good fit for us at this point. So thank you for your time this morning.
Thank you so much, Robin. Okay, our next presenter is Jeremy Stewart. He's one of the lead power analysts at Tacoma Power, and he's heading up several utility programs, including their electric transportation program. He is currently leading a school bus microgrid project and port electrification, which I look forward to hearing too. Take it away, Jeremy.
Great. Thanks, Christine. Appreciate it. Thanks, everybody, for taking the time to listen to us today and talk about Some of the big picture stuff that we're seeing as a utility as far as coming up with fleet electrification, really from the utility point of view, and hopefully we can use that to electrify more things. I'm going to go ahead and share my screen here real quick. All right, hope everybody can see that okay. So this is really about building zero energy infrastructure to support medium and heavy duty vehicles. As I said, we're kind of taking this from a utility point of view. So, and the utility point of view, it really depends on where you're set. So for Tacoma Power, we have clean renewable power provided by 4 hydroelectric projects. We get about 40% of our power from our own hydroelectric resources and about 60% from a BPA contract, which is also hydroelectric. So our power supply is about 98% carbon free. We got supported policy with the climate action plan and internal electrification transportation plan. And we see a lot of supportive policy on green hydrogen. And we have a target rich environment. Tacoma Power is situated along I-5. We have the Port of Tacoma. There's a terminus of a couple of major railroads. We have a sister utility that is a municipal beltline railroad. So there's a lot of like cargo-y, fleety things that kind of like stop by Tacoma and utilize our services here. So the scale of the challenge really changes when you go from light duty to medium duty. So when you got a light duty vehicle, you're looking at a 50 to 100 kilowatt hour battery. Most of these things can be charged overnight to meet most customer needs. You're going to see some DCFC charging somewhere, but even DCFC for these pieces of equipment is like 50 to 150 kilowatts. So, small batteries, most of them can be met with a level 2 charging option, occasional DCFC. When we compare and contrast to what we see with medium heavy duty, the batteries are much, much larger. You're looking at 600 to 900 kilowatts, maybe even more. 50% of it has been estimated will need some type of like overnight DCFC in the 50 to 100 kilowatt range. So your average charge size overnight is going to be larger. Plus, there's going to be a lot of opportunity charging. And we've seen numbers ranging anywhere from 350 kilowatts to 1 megawatt. It's just a very different scale and moves on from these like, the load of a water heater or a residential dryer into something that looks like much more of an industrial load classification. So trying to figure out how we integrate these things is an interesting challenge. And I had somebody one time say that it's really like if you use a banana for scale, that can give people an idea. Light duty, once again, got a couple of these things at single family residences. You're not triggering utility upgrades. Managed charging programs can help. But moving to meet that medium and heavy duty load, you've got existing sites that just aren't ready for this type of thing. Franklin Pierce's school district is kind of unique because the bus transportation facility shares the same electrical infrastructure as the high school campus, which has a very large electric heating driven load. So you have a lot of capacity at the building, but there's a lot of places that aren't anywhere near on our radar as big customers that if they transition 10, 20, 30 vehicles to a medium or heavy duty fleet, they're all of a sudden going to become large key accounts. So that's a challenge of us. The other thing is that EVSE capacity versus managed charging. There's this real drive by a lot of the OEMs to push the biggest, fastest chargers that they can get. And then once you go try to install that in a building, all of a sudden you quickly max out that building's capacity. So, we're talking to customers about managed charging. What are their opportunities there? So sometimes they're hearing conflicting messages from us and the OEMs. And just the duty cycles of medium and heavy duty means you're going to have less opportunities for managed charging. It's not feasible to have a truck drive for 4 hours and then let it sit for 4 hours to charge and then start driving again. Typically, that's not going to fit within a duty cycle. So we have to be cognizant about what the customer needs and make sure that we can meet their needs with how we're going to provide load. So this leads us as utility to kind of like, on one hand and on the other hand type situation. So we're very supportive of electrification because it supports decarbonization. And, our city council has been a very big advocate of that. We're looking to utilize our clean resource to help with that. It increases retail energy sales, which in general for the utility is a good thing. And we really want to be a partner with customer to avoid lost opportunity. So how can we work with customers today to make sure that we kind of future-proof what they do and what they're putting in place? But then on the other hand, the equipment is all behind the customer meter. And that creates a lot of challenge for us because it's not necessarily owned by us. And there's a lot of business models that say maybe it should be owned by us. And then you end up in this really nebulous place about who's responsible for what, who's maintaining the equipment. It creates a whole lot of challenges. There's also we have a conservative investments to keep our costs low, which, some of these pieces of equipment are fairly expensive, and there's a fear of stranded assets. If a customer comes to us and they want us to build infrastructure to support 5 megawatts worth of charging load at a warehouse, and then they turn around and don't electrify the fleet, that's a lot of money that we have put on our other ratepayers to now support that. And that all kind of comes to the socialization of cost and equity. At the end of the day, fleets are electrifying, and it's a big benefit for the fleet customers. It's a benefit for society too, but should, Tacoma Power customers, a third of which qualify as low income, be supporting, private business. So those are things that we're wrestling with, and we're trying to figure out ways to kind of equitably support transportation electrification, as well as do it in a way that works for everybody. So what are we looking for as a utility when we're looking at programs? We're looking really for kind of 3 things. The first thing we want to do is we want to shift charging outside of peak hours. And for us at Tacoma Power, that is between about 4 p.m. and 9 p.m. in the evening, and about that same time in the morning, about 5 a.m. to 9 a.m. in the morning. Shifting that allows us to realign the load with what we see from our wholesale prices and what we see from our generation resources. So it's, people will ask me, hey, Jeremy, what's going to happen when everybody goes and buys an electric car and plugs it in? Well, if everybody today went out and bought an electric car today and everybody plugged in at 6 p.m. today, we'd have a lot of problems. But, electrification is going to be a 20 to 30 year project. And as we kind of go on to that, if we shift out that load and figure out a way to kind of smooth that out, it's going to solve those problems. So we're looking to shift the charging outside of peak times, which for the case of overnight charging and level 2 charging can usually be done. The other thing we're looking to do is minimize the overall demand. So the demand from electric vehicles can be pretty extensive. I was working with a customer the other day. They were looking to build a new warehouse. They wanted to future-proof the warehouse building. They kind of put together they put together what they thought the transportation load might look like in 20 years. And they were asking for a 4.5 megawatt service for a building. And we were trying to work with the customer to find ways that we could minimize what that demand is. One of the challenges is that the real estate folks don't want to put like restrictions on how customers use capacity. They just want to put in a really big service. So there you've got the challenge of how do we meet that, how do we meet that demand, but we also make it good for the customer. And finally, stranded assets. Going back to that same warehouse I talked about, if we put a 4.5 megawatt feed into that warehouse and that customer ends up, not having the electric fleet, or they don't electrify that fleet, that's a lot of expense that is put in place to kind of serve that one customer. Now, there's a lot of ways that we can meet this goal, and these are things that the utility is kind of like looking at. So we're looking at like fleet managed programs, and we're kind of thinking of this as 2 different animals. One animal is customers who run single shift operations, kind of similar to, could be something like Franklin Pierce, could be a warehouse where they're running 1 shift in a day, and then they have like a period of time when they can charge vehicles. So for those customers, offering some money up front to get a managed charging in order to minimize that overall demand. So instead of charging all the vehicles at the same time, cascade them, vehicle A, vehicle B, vehicle C, and then go ahead and shift that start time out to a time that's advantageous. So we're looking at ways to do that, support customers with some of their upfront capital costs, and then maybe kind of put some type of rate into effect in order to reduce their kind of long-term ownership costs. So that's kind of like one strategy that we're looking at. The other one that we kind of see deployed with Franklin Pierce and school buses kind of really applies to some of these vehicles that require fast charging turnaround. And when you start to get multiple vehicles that are all going to use fast charging and they're all going to have a coincident peak, you really need to look at battery storage. And that's what we found with Franklin Pierce. You can manage the level 2, that's great. But if you have these peaks that kind of show up, the battery is going to really help with the demand charges. Now we've got pretty low rates, and that applies both to demand charge as well as our volumetric or per kilowatt hour rate. Our customers that are using a Schedule G, which is our kind of our standard service category, they're at about 4.5 cents a kilowatt hour, and then they're about $9 a kilowatt. So pretty low from what I've seen from other utilities. Taking those numbers and applying fast charging equipment, if it can avoid demand charges, or battery backed up equipment that can avoid demand charges, it pencils from the customer's perspective over a 7-year period. It's long, but it's a good investment for the customer, because what it's going to mean is they avoid paying those demand charges if they have a coincident peak issue. So we see lots of ways that so programs for those fleets are going to kind of look at ways that we can mitigate that peak demand, because that's going to be a real challenge, not only for us, but for those customers as well. So the other thing kind of leave off with is not all charging stations are the same. And there's kind of like 3, when you talk about, fleets of vehicles and where they charge at, there's kind of 3 different things that we see out there. So one is at depot charging. And from a utility perspective, we like depot charging. This one's would be classified as the easier one. You've got a fleet, they all park overnight, they have a dedicated site, they have a known load and a known schedule. It's owned and maintained by the fleet owner. Most of the risk is on the business owner. They're the ones who are going to be spending most of the investment. This is the type of charging thing that utilities can really work to provide solutions for customers to help them out. Then you've got a lot of fleets where the employees take their cars home with them. And we kind of run into this with some of our police fleets. The vehicle is overnight at the employee home. And it's complicated because now you're talking about potentially subsidizing a charger at an employee's home. That kind of gets a little strange, as far as from the various businesses and stuff, and it's competing with the existing home. And there's some ambiguity between who's the owner. Is it the homeowner, is the fleet owner? And it kind of puts the risk on the business owner and on the employee. So this one's kind of a challenge, but this is one that we're gonna have to figure out and we're gonna have to overcome. And then on the third round, we look at like a public fueling station. And there's a lot of interest in having the utility build public fueling stations, but these are very problematic. Your location is going to be a truck stop or some publicly available facility. I'm not convinced fleets are going to park the vehicles overnight, not on site. And maybe I'm wrong. We're still doing research on that. The use it's a very speculative thing where you have to build this to support a lot of different demands. There's some challenges there. There's some ownership as far as who's owning it. Is it a utility? Is it a private-public partnership? Is it the fleets? And it really takes the risk and dumps the risk on, one or two entities like the utility or the business owner, and the fleet kind of gets a free ride from the risk. So, these are challenging. We're looking at how they're going to fit within kind of our long-term strategy, but we're, looking at options there. So that's kind of like what very brief presentation of what I have. I'll go ahead and finish up a little early and yield some of that time and hopefully have some good questions at the end. So thanks for listening, everybody.
Thank you so much, Jeremy. That was fascinating. So next we are turning our attention to Carly Macias. So we've heard from a school district, we've heard utility perspective, and now Carly is going to talk about King County Metro and their unique challenges and what they've been experiencing. So Carly is a zero emission fleet strategic planning manager at King County Metro, working with zero emission vehicle planning and deployment. She is also currently the chair of the American Public Transportation Association Zero Emission Fleet Committee. That's a mouthful. Welcome, Carly.
Thank you. Is my PowerPoint full screen now?
Yes.
Great. Thank you so much. So again, I'm Carly Macias. I'm with King County Metro. I'm excited to give a little bit of an overview of what we're doing at King County, but then also a little bit of a perspective on the transit agency industry as a whole and what kind of how the whole industry is moving to zero emission. But just to give a little context, King County Metro is one of the largest transit agencies in the country, actually. We have over 1,400 buses, which is a pretty large fleet. We also have lots of other different vehicle types. So van pull vehicles, cutaways, which are kind of shuttle type vehicles, water taxis, non-revenue vehicles, which is all of our support vehicles. And then we offer a lot of, folks in the King County, Puget Sound region transit service every day. So about, over 200,000 rides every weekday. That was a lot higher, obviously, before COVID, but we are seeing that ridership really recovering. So we have a very robust service and lots of different vehicles. So you can see how that could be challenging to transition all these really different vehicle types and trying to go zero emission. I will say, I like to use the term zero emission. Right now, we are primarily looking at battery electric vehicles, but I do see a future where maybe there are other types of zero emission vehicles as well. So just a little overview, why are we doing this? I think this is probably clear to most people, but, transportation is one of the biggest sources of emissions. On the left there, you can see this is for the US as a whole. In 2020, transportation made up over a quarter of those emissions. But in Washington state, it's actually a lot higher. Almost 40% of greenhouse gas emissions are from transportation. The interesting thing is that transit does not make up a very large amount of those emissions. So you can see, I think it's about maybe 1% of that 40% for Washington for that transit service. And that's not to say that we shouldn't go zero emission. I think it's more that transit can have multiple impacts on reducing emissions in the region. So not only are we getting people out of their cars and onto transit, so not having their own emissions from their gas-powered vehicles, but if we can also operate a zero emission fleet, then we can really have a huge impact on multiple fronts. And I think we also see ourselves as really leading the heavy duty industry in terms of going zero emission. Because we are government funded, we're able to get grants and different things to really push the technology and kind of prove it out for some of those other heavy duty sectors. And maybe kind of provide a way for them to go zero emission, so like the trucking industry and others. So we see ourselves as really leading both the transit industry, our region, and maybe even the heavy duty sector. So I think in all of those ways, we can have a huge impact on reducing emissions and really kind of impacting the climate crisis. So I know there's a lot on this slide. I'm going to highlight a few things, but I was hoping, if we send out these slide decks, it'd be nice for folks to have all of this information. So King County does have a strategic climate action plan. And this is for the county as a whole, and King County Metro is a part of that. But a huge way that we're going to reduce emissions is by transitioning all of Metro's fleets to zero emission. So, our bus fleet is a significant part of our emissions with those 1,400 plus buses. But we do have lots of other vehicle types, as I mentioned before. So the goal that we're really, we're focused on all of these, but right now we're really pushing on the goal to get our bus fleet to 100% zero emission by 2035. We're also looking at our ADA paratransit vehicles, which is more of that shuttle type of vehicle. There's fewer of those on the market right now, but we are optimistic that there will be a lot of market growth and more options for us to look at in terms of battery electric or even hydrogen fuel cell vehicles. On the light duty side, there's a lot more options. So we're hoping to get to 50% electric by 2025 and 100% zero emission by 2030. On the heavy duty side, you can see those goals are a little bit later, just because, for things like, fire trucks or garbage trucks or large vehicles, there's not as many options right now. So we're really pushing the envelope where we can, where there is a current market, where there are viable vehicles. So I think, all of these are kind of moving forward, and we're really trying to reduce emissions everywhere, but kind of making the biggest impact where we can in the moment. And then I did just want to mention we are installing EV chargers for light duty vehicles at different locations like our park and rides. So our customers that own EVs can also use our facilities to charge. And our goal is to have 125 chargers by 2030 at those park and rides. Another goal that we have as part of our climate action plan is to really partner with communities to invest in those communities where they have been disproportionately impacted by climate change. So one of the ways that we are doing that, and there are multiple ways that the county is dealing with that issue, but for Metro specifically, we are trying to deploy those zero emission buses first to the communities that have the disproportionate burden of air pollution. So by reducing the number of diesel buses running through those communities and having zero tailpipe emissions, we think we can really start making an immediate impact on those communities. Obviously, transit is not the biggest emitter, but I think it can help those communities to at least not have those loud kind of emitting diesel buses running through there. So one of the ways that we're doing that is really focusing our deployments in South King County is one area we've identified. And that's where we have our South-based test facility. And that's where we're really trying to understand how all of the new technologies are working together, testing out, fast charging and, slower depot charging. So we really did want to focus a lot of our initial investments in those communities that had poor air quality. And I'm going through this really quick. I'm hoping I can get some questions at the end from folks that want to hear more about this. This is just a bit of a visual of how we're envisioning this transition will occur. So you can see, we already made a huge transition from diesel buses to diesel hybrid buses. So I think we've already made an impact by making that huge transition. But as you can see over time, we do want to transition more and more of those diesel hybrid buses to battery electric buses. Unfortunately, we can't do that overnight because of the way that we're funded. So every time you buy a bus that's been funded with the Federal Transit Administration funding, you do have to keep those buses for at least 12 years, just so the taxpayer money is well spent. You're not getting rid of buses that still have a useful life. So that is what kind of causes that slow ramp up of transitioning to battery electric buses. And I did just want to highlight our electric trolley buses are definitely part of our zero emission transition strategy. Those are zero emission buses. They just draw their power from wires instead of being charged kind of at speed, maybe at your facility or en route. So that's definitely an area where we want to potentially expand trolley buses, or at least maintain the fleet that we have, because it's really the backbone of the zero emission service right now. So go to the next one. So this is just a little bit of an outline of our near-term projects. Our goal to get to zero emission by 2035 will include a lot more than this. Christine, am I like 2 minutes?
Yep, you have 2 minutes.
Great. All right. So as I mentioned, we recently opened our South-based test facility. We have 40 battery electric buses that are operating out of that facility. And we are in progress on a transit system electrification study that's really going to help us outline exactly what that transition looks like. I think we've got the broad brush strokes sort of, but we need to get down into those details. Since we have 9 bases, it's going to take quite a bit of time and effort to convert each base to be capable of hosting those electric buses. In 2025 is going to be a big moment where we open our interim base, And that will be able to support 120 battery electric buses, which would be a huge increase in the number of zero emission buses in our fleet. We're also looking at putting layover charging at strategic points. So those buses can maybe have a longer range, be able to stay out in service longer by charging up at transit centers in different places. And then around 2028, we'll be opening our South Annex space, and that will be able to support about 250 battery electric buses. So you can see the scale that we're going and how quickly we're getting there. I think is pretty ambitious and exciting. So I'm not going to cover each of these points, but this could be maybe a topic for Q&A. But some of the risks that we see in the future are, workforce training and recruitment. I think this is a challenge across all industries, but really having folks that are skilled to work on these electric vehicles can be a challenge. And if you do train them, sometimes they get kind of stolen away by other industries that also need folks that can maintain and operate electric vehicles. We also need to, really be focused on partnering with our partner agencies and coordinating, obviously with our utilities is a huge part of that, just because of the amount of power we're going to need at all of these facilities. There's a long lead time for that. Supply chain has been an issue in terms of getting these vehicles and chargers delivered on time, which is, again, something that is industry-wide. We're also hoping that there's going to be more guidance on standards so that you do have chargers that can work with different types of vehicles. So if each manufacturer is making their own charger with no standard, then you end up with sometimes assets that can't be used in the future, or it can only be used with one type of vehicle. But I just want to go to the next slide very briefly. So I'm actually very involved with the American Public Transportation Association, which is APTA, and I'm the chair of the Zero Emission Fleet Committee, so I wanted to plug that a little bit. But there are other professional organizations where we're talking about these industry-wide issues and things that people are worried about. So limited range on these vehicles, we're hoping that'll improve over time with larger batteries. Space requirements for infrastructure can be a big challenge. You might need more facility space in the future if a lot of that space is being taken up by chargers and electrical equipment. Thermal events, I know it's not something everybody likes to talk about. Electric vehicle fires are very rare compared to combustion engines, but they are difficult to put out. So that is something that we're thinking about in terms of kind of deploying these vehicles, is how do we make sure that we're prepared and also preventing those from happening. But I think I might leave it there and just use these bullets as an opportunity if anybody wants to ask any questions.
Great, thank you so much, Carly. That was very interesting. So I'm going to ask the panel a few questions first, then we're going to open it up to the public. Carly, I'll start with you. How many e-buses do you currently have? And I think from slide 7, it looked like you had over 200 as of 2023. And
no, sorry. That would be a lot. Actually, I think that slide showed that we will have that many by 2028, or I'm trying to think of what slide you were thinking of.
Slide 7. It had the diesel hybrid, it had the trolleys, electric trolleys, and it had electric buses.
Oh,
I call the trolley a bus. I was saying, I should say electric vehicles.
Yes.
Yeah.
So we have 174 electric trolley buses. So that's the bulk of our zero emission fleet currently. And then we have 40 battery electric buses. So right now we are very experienced with our electric trolley buses and kind of developing our battery electric bus fleet.
Gotcha. And I know you have a fleet of 1,400 buses. Have you been in conversations with the manufacturers given the supply chain issues, and can they deliver those by 2035, do you think?
Yes, so I think it will be a challenge, but they see this coming, especially with the federal funding that's really sped things up. The FTA has the Low or No Emission Vehicle Grant Program that has, I think it's like quadrupled the amount of funding for zero emission buses. And so every manufacturer is ramping up their production, and they're actually slowing down their production on other vehicle types like diesel and CNG buses in order to shift over to manufacturing those zero emission buses. So we're feeling confident that they're going to be able to deliver, but it will be a challenge.
Thank you so much. And so while we're on the bus topic, Robin, what are your plans for future fleet transitioning, one, and two, you had mentioned a price for the level 2 charging around 10K, and saying that, you know, you really need the DC fast charging. Did you happen to get a price point for the fast charging? It's my other question.
Yes, thank you. To the last question, yeah, the fast chargers are very expensive. The ones that we chose are actually more expensive than the ones that don't have battery backup.
Yeah.
And I think we will be over 400,000 in purchasing and installing 2 of those units.
So what's the bulk of that? Is it the installation charge, or just the conductoring and the setting up the infrastructure? What makes up the 400,000?
So the bulk of that is made up by the cost of the charger itself. It's very expensive. The we were fortunate that we didn't have to change out our transformer. That was part of our calculus in going this direction. So that would have, of course, increased the cost a lot more, but we were able to use our existing transformer, and we did have to trench over to a distribution panel and run conductors. So that's about 50,000.
Okay, and those are 150 kW chargers?
These are, yeah, I don't remember, but yeah.
Probably 150. Thank you so much. And what about your plans for? Do you have anything on the books for more than 4 buses?
So we, like I said, we are kind of tapping the brakes right now on additional deployment, waiting for the market to bring maybe a bus with more range so that we can rely more on level 2 chargers. But we have capacity with the existing transformer to put in 4 more double-headed fast chargers. So we're just kind of waiting for grant opportunities and for the industry to kind of mature a little bit.
Gotcha. Thank you so much, Robin. So we do have some questions in the chat, but I just wanted to ask Jeremy a super quick question. Have you estimated the impact of full fleet electrification in your service territory, and what would that impact would be on your supply side resources, like how many more megawatts you would need, or even just for the Port of Tacoma? Have you done that analysis yet?
Those are actually 2 studies that are currently in progress right now. So the Port of Tacoma is actually doing its own electrification study, and we're doing a service territory-wide study. So don't have hard information yet, but hopefully we'll next year.
Okay, wonderful. Thank you so much. So we have a lot of questions in the chat. Let's see here. So from Ralph Trout, Sanders, there are only 2 conductive charging standards for medium heavy duty charging. You spoke of an issue with standards. Please explain.
I think that was mine, and I did just answer in the chat.
Oh, okay.
But just very briefly, there's not currently a heavy duty standard for inductive charging, which is something that a lot of transit agencies are really interested in. So that would be kind of that wireless embedded charging. And so we're waiting on that from SAE. But also I think there could be some more detail and improvements in the current standards, which I think is already happening. Yeah, I won't take too much time talking about standards.
Okay. And on-site energy storage, can you provide business case studies that were used to show that for a schoolyard, a 250 kW, 550 kWh battery was the right choice?
I don't know, they're asking one for me or Robin. I don't have anything, I don't have a formal business case. I've done some back of the envelope calculations.
Yeah, so was that your choice of battery size, the 250 kW? Looks like it was a 2-hour battery. Was that the choice of battery size?
I mean, the free wire battery, to my knowledge, is either 150 kilowatt hour or 200 kilowatt hour. But
Okay.
I think they're asking about a specific battery spec. But
Yeah.
like in general, you know, as I said, I've done a back of the envelope calculation.
Okay, thank you. And then I received another question for you, Robin. Have other school districts reach out to you? And you mentioned that you're small, compact district. Do you think that bus electrification, even on a small scale, would work in rural areas, rural school districts?
We have had other school districts reach out to us about our experience, especially early on, where, you know, they were trying to figure out some of the initial considerations that we had worked with and about maintenance and the like. As to the rural applicability of the technology, I guess you'd have to be very careful because I don't see right now with ranges that are available on the market that the battery powered electrical vehicle would be suitable for long runs in a rural district. I mean, if there were short runs, certainly, but the districts that are coming to mind are fairly large geographically and have long bus routes. And I think that they would find that a challenge at this point.
Great. Thanks, Robin. Let's see here. And Judd Verdon from PNNL, he asks, first he says, great presentations. Are there additional analysis tools that would be valuable for evaluating grid modernization, cost and reliability, modernization efforts to accommodate the increased load? If you don't know of tools, I can talk to it a little bit. I know, yeah, PNNL, you know, as part of the Franklin Pierce, we looked at load and building integration to help understand the applications of battery storage, as well as smart charging, demand response. And we also looked, through our EVs at scale, we looked at the wholesale level of adding mass electrification onto the grid and some of the challenges and resources required to meet that additional load. So that may be used to kind of trickle down to smaller areas to help identify your particular load needs. Let's see here. Okay. And so, Jeremy, in just one more minute, so can you tell us a little bit more about what you're doing at the port with regards to port electrification, or what stage you're at?
Well, the port's the one that's taking the lead on it, but right now they're conducting a study to look at what happens if they electrify everything. So they're kind of doing that on a facility by facility basis, and then we're working with them to take those results and see what happens when we run those results into our system to try to figure out what a master plan for like 30 years out would look like. So, I would assume, large organizations that have like many pieces of equipment, particularly ones that are going to need to be fast charging, I would start talking to your utility now to try to at least get on their radar that you've got these things coming. That way it's not a surprise. And a lot of times if you're when we have to build a substation to accommodate new load, a lot of times there's extra capacity in that substation, but knowing that there's a big load coming in a different place allows us to make a different decision about where that substation goes, or maybe how big it is or how expandable it can be. So talking to us early is very important, particularly if you've got a lot of vehicles that are going to be on fast charging.
Excellent, thank you. Well, I want to thank you all so much for being here. Your presentations were excellent and very informative. I know I've learned a lot, and I appreciate the opportunity to work with you and hope we get to work together in the future. So thank you. And if I learn of any other questions, I will forward them on to you. And I do want to introduce our the next webinar series will be on July 20th on energy storage for grid resilience. So please join us here for the PNNL battery storage webinar series. Thank you again, panelists. Have a great day.
Thanks, everybody.
Thank you.
Bye.